Okay everybody, let's take a look at some very important questions now. The question coming up is that in an equilateral triangle ABC, D is a point on side BC such that BD is 1/3 of BC. Prove that 9AD square is 7AB square. So all these things will be clear to you once you're through with the diagram. So you have a triangle ABC. So say this is your triangle ABC and this is equilateral triangle. So I am saying each side is of same length and the length is A. Okay, let us assume each side is of the same length and the length is A. From A, D is a point on side BC such that BD is 1/3 of BC. So you have this point, what is it? D. So let me say this is E and AE is perpendicular to BC, and say somewhere this is the point D such that BD is 1/3 of BC, but BC is of length A, so this is 1/3 of A, so BD is A by 3. What I need to show? I need to show 9 times AD square is 7 times AB square. If you try to focus, what did I do? I drew a perpendicular from A on side BC. Now please don't forget this is an equilateral triangle. So this particular perpendicular that is being drawn in here is actually from this triangle giving you two triangles, which is triangle ABE and triangle ACE. If you focus on these two triangles, triangle ABE and triangle ACE, you can see that triangle AEB is same as angle AEC. Angle AEB is same as angle AEC, which is 90 degrees. Side AB of this triangle is same as side AC of this triangle, because it is an equilateral triangle, so both sides are of length small a, and AE is the common side. So by right angle hypotenuse side congruence condition, I can say triangle ABE is congruent to triangle ACE. Triangle ABE is congruent to triangle ACE. The moment I say triangle ABE is congruent to triangle ACE, I get that by CPCT, BE is same as EC. If BE is same as EC by CPCT, this implies E is the midpoint of BC, obviously. And if E is the midpoint, that means E is dividing this entire segment BC into two equal parts. So if this complete length is A, that means BE is A by 2 and EC is also A by 2. Right? It's half of A, half of A, and that is because E is the midpoint of BC, and that we got by the congruence rule of these two triangles, triangle AEB and triangle AEC, okay, by RHS congruence condition. Now that I have this over here, I have got the length of BE with me, which is A by 2. I know that DE can be written as BE minus BD. You can check. BE can be written as, or I should say DE can be written as BE minus BD. So DE I don't know, but BE I know is A by 2 and BD I know is A by 3. So this turns out to be 3A minus 2A by 6, which is A by 6. So you have got the length of DE. So DE is there with you. Now if you focus in triangle ABE, which is a right angled triangle, right angled at E, you know hypotenuse square is equals to base square plus perpendicular square. So hypotenuse square is AB square is equals to base square is BE square plus perpendicular square is AE square. I need to compute the length AE, so I will have what? AB square minus BE square is AE square. So AB square is A square, BE square is A by 2 square is equal to AE square. Right. So this gives you A square minus A square by 4, which is 4A square minus A square by 4, which gives you AE square is equals to 3A square by 4, which implies AE is root 3A by 2. There is no question of taking plus minus, it obviously will be plus because this is, we are talking about the side length, it can never be negative. So AE you have got as root 3a by 2. So you have got AE with you, you have DE with you. So you focus on this right angled triangle AED now. So in triangle AED, you know hypotenuse square is equals to base square plus perpendicular square. So in triangle ADE, AD is the hypotenuse, DE is the base and AE is the perpendicular. So AD square is equal to AE square plus DE square. AE square, AE is this, so AE square will be 3a square by 4 plus DE square, so DE square will be a square by 36. Your complete LCM will be 36. 4 into 9 is 36, so 9 into 3 is 27a square plus a square, which gives you 28a square by 36, which gives you what? This is 14. Let me just write it down. This is 18, this is 7 and this is 9. So you get 7a square by 9. If now you see you have AD square is 7 by 9a square, you know that you have to show AD square is 7 by 9 of AB square and AB is of length small a. So you have got AD square is 7 by 9 of small a square, that means AB square because AB's length is small a, or you can write it as 9 times AD square is 7AB square, it is the same thing. And that's how you proceed ahead to prove this very, very important conclusion related to this equilateral triangle. It's one of the most important questions which has great probability to be asked in your paper. Let's talk about the next question. It says that if q 0, 1 is equidistant from these 2 points, then find the value of x. So it's already given to me that there is this point which is equidistant from 2 points. That means I have point P with me whose coordinates are 5, minus 3, and then I have this point Q which is 0, 1, and there is a distance between P and Q, that is PQ, or the length of the line segment PQ, which is same as the distance of Q from R whose coordinates are x, 6. So it's given to you that PQ is same as QR. That means you have, use the distance formula, 0 minus 5 whole square, that means 25. So x2 minus x1 whole square plus y2 minus y1, 1 minus minus 3, that means 1 plus 3, that is 4 whole square, which is 16, is equal to root over the distance between q and r, which is x minus 0 whole square plus 6 minus 1 whole square. So x2 minus x1 whole square plus y2 minus y1 whole square, here you had 0 minus 5, that is minus 5 whole square plus 1 minus minus 3, that is 1 plus 3, that is 4 whole square. Squaring both sides gives you 41 is equals to x square plus 25. So x square will be 41 minus 25, which gives you 16, which implies x is plus minus 4. So there are two options with r. R can be 4, 6 or r can be minus 4, 6. Okay, two possibilities for r. If r is 4, 6, then also PQ is same as QR, and if r is minus 4, 6, then also PQ is same as QR. So with both these r's, I will calculate the distances QR and PR. So QR, that is distance between Q and R. So let me write the point Q is 0, 1, and I am taking my R as 4, 6. This is QR and PR. So P is my point 5, minus 3, and my R is 4, 6. So I have to calculate QR and PR. So QR will be positive square root of 4 minus 0 whole square plus 6 minus 1 whole square, which is root 41, and PR is equal to 4 minus 5 whole square plus 6 minus minus 3, that is, what is 6 minus minus 3? That means 6 plus 3, that is 9 whole square, which is 81. So this is root 82. Similarly, if I take up the other R, which is this, Then I find my QR and PR. So in that case, my QR is going to be minus 4 minus 0 whole square plus 6 minus 1 whole square. This is again root 41. Fine. And then you want to calculate PR. PR minus 4 minus 5, that is 9 whole square, which is 81, plus 6 minus minus 3, which is again 9 whole square, which is 81. So it is 2 times 81 square root, which is root 2 into 9, that is 9 root 2. 81 plus 81 is twice of 81, right? So root 2 into root 81, root 2 as it is, and root 81 is 9. So this is what you have as QR and PR if you take this as R. So with both the R's, I have calculated the distance QR and PR, and that is your complete solution. Application of distance formula, we have moved towards coordinate geometry now. Talking about the next question, it says if A and B are these 2 points, so the coordinates are given to me, then find the coordinates of P such that AP is 3 by 7 of AB and P lies on the line segment AB. So P is a point lying on the line segment AB, that means over here internal division is being considered, not external. So this is A, this is B, somewhere on the line segment AB, P is lying, A has coordinates minus 2 comma minus 2 and B has coordinates 2 comma minus 4. I have to find the coordinates of P such that AP is 3 by 7 of AB. So if AP is 3 by 7 of AB, that means AP upon AB is 3 upon 7. So it's given to me that AP upon AB is 3 by 7. So obviously this will have to be 4, and I will get that AP upon PB therefore is 3 by 4, right? So now I don't need this complete 7, I have got the ratio 3:4 in which point P is dividing the line segment AB, but it was not directly given to me, it was given to me in an indirect fashion. We had to come to this conclusion that AP is to PB is 3 upon 4 or 3:4, because AP is to AB is 3:7 or PB is to AB is 4:7. Anything could have been given to you. In that case, you would have got 4 already, you would have concluded about 3. Here you have got 3 already, you concluded about 4. Okay. The moment I have got this ratio, now I just need to directly use the section formula to get the coordinates x and y. So x will be m1 x2 plus m2 x1 upon m1 plus m2, and y is m1 y2 plus m2 y1 upon m1 plus m2. So m1 x2, 3 into 2 is 6, m1 x2 plus m2 x1 minus 8 upon m1 plus m2, and y is m1 y2 minus 12, 3 into minus 4, m1 y2 plus m2 y1, so minus 8 upon m1 plus m2. So this is minus 2 by 7 and this is minus 20 by 7. Therefore, coordinates of P are minus 2 by 7 and minus 20 by 7. Is it clear? After this, we move ahead towards the next question. It says that in each of the following, find the value of k for which the following points are collinear. So there are 2 pairs of points given to me. When do you say that the 3 points are collinear or lying on the same line? Whenever by this triangle approach, if I go, then say A is this point 7 comma minus 2, B is 5 comma 1, 3 comma k. Now these 3 points can be collinear if and only if they lie on one single line. That means if I treat them as vertices of a triangle, then this triangle has no area, 0 area. It is not a full-fledged triangle being seen on the board or on the paper. So these 3 points are collinear, it is given to me, that means the area of the triangle of which these 3 are vertices is 0. So you have area of the triangle ABC is 0, that means half of, what's the formula? Half of x1 y2 minus y3 plus x2 y3 minus y1 plus x2 y3 minus y1 plus x3 y1 minus y2. Let's check once again. I am taking this as x1, this is y1, this is x2, this is y2, this is x3, this is y3. So you have x1, y2 minus y3. So it's x1, y2 minus y3. This is 1 minus k. Half x1, y2 minus y3 plus x2, y3 minus y1, fine, plus x3, y1 minus y2. This area actually is mod also. This area is 0. But you know, mod of anything is 0 if and only if that thing is 0. So mod of this thing is 0 implies this thing is 0, and half into anything is 0 means that thing is 0. So even half you can remove. So you have got this as 0, which eventually means 7 minus 7k plus 5k plus 10. This is minus 3, so this is minus 9. So you have 7 plus, or I should say 10 minus 9 is 1, 1 plus 7 is 8, minus 2k, because minus 7 plus 5 is minus 2 is 0. So 2k is 8 or k is 4. So you have got, this is the value of k for which these 3 points are collinear. And if I talk about the next pair of points, say again I name it as ABC, this is 8, 1, k, minus 4, and you have 2, minus 5. These 3 are collinear, so again area of this triangle ABC is 0 because they are lying on one single line. So you have got x1, that is 8, x1, y2 minus y3, so minus 4 plus 5 it will become, plus x2, y3 minus y1 minus 5 minus 1 plus x3, y1 minus y2. Okay. So let me write, this is x1, y1, x2, y2, x3, y3. So you have half x1, y2 minus y3, so minus 4 plus 5, plus x2, that is k, y3 minus y1 minus 5 minus 1, plus x3, that is 2, y1 minus y2. So this is what you have got. So you have 8 into 5 minus 4 is 1, so this is 8. Then this is minus 6k plus 10 is equal to 0. 10 plus 8 is 18 is equals to 6k. So k is 3. So you have solved these 2 problems. Okay. What is the value of k for which these 3 points are collinear? You are supposed to do it by this method. It's really simple and fetches you with the solution very, very easily. Then I have in triangle PQR. So we are heading towards now trigonometry. What is it trying to say? In triangle PQR, right angled at Q. So the triangle is given to me as something like this. Okay, right angled at Q. PR plus QR is 25. So PR plus QR is 25. Okay, PR plus QR is 25. So I can say one thing, let PR be equal to x, then QR is 25 minus x. Right, let PR be x, then QR is 25 minus x. It is also given to me that PQ is 5 centimeters. So PR is x centimeters, QR is 25 minus x centimeters, so PQ is 5 centimeters. And therefore now I am only going to see that Pythagoras theorem can be applied. So PR square is equals to QR square plus PQ square. So PR square is x square is equals to QR square, that means 25 minus x whole square plus PQ square, that is 25. Right, because PQ is 5, so PQ square is 25. So you have this square plus this square is x square. So x square turns out to be 25 into 25 is 625 plus x square minus 2 into x into 25, which is 50x plus 25. Clear? So you have x square actually gets cancelled out. you are left with 50x equals 625 plus 25. So this gives you 5 plus 5 is 10, 2 to 4, 5, so 650. Fine, because x square gets cancelled out, then you have 50x is equals to 625 plus 25, which is 650. So x